See Standard 12th Maths, Chapter 10, Ordinary Differential Equations, Exercise 10.8, Sum 5. Suppose a person deposits 10,000 Indian rupees in a bank account at the rate of 5% per annum, compounded continuously. How much money will be in his bank account 18 months later? So the person deposits 10,000 rupees in the bank. Initial amount is 10,000 rupees. The rate of interest is given as 5%. Question up to this one. Compounded continuously. How much money will he be in his bank account after 18 months? So let me take the principal be P. Let P be the principal. At time t. At time t. T is in years. In years. And let me take the rate of interest as R. R be the rate of interest given for you, 5%. Rate of be the rate of interest. Rate of interest. So the principal P in time t, the rate of changes in the principal is directly proportional to the P amount. So dP by P by dt, dt is equal to some constant. That constant is rate of interest, P. They given K, constant. They already given for you as the rate of interest. Constant, this is our rate of interest. So, that is K is 5%. 5 by 100, 0.05. So dP by, bring down this P is equal to K dt. K into dt. So integrate log P, K constant, Kt plus C. So initially at time t is equal to 0, our principal is 10,000. And the rate of interest is given for you 0.05. 0.05. So here, before that, you just simplify this. E power log P is equal to e power Kt plus C. So P is equal to e power Kt into e power C. Let me take that as some constant C. So, P is 10,000 is equal to C e power 0. So, P is 10,000. So, our equation becomes P is equal to 10,000 e power Kt. E power Kt is e power 0.05 T. 0.05 T, K given for you, rate of interest. Come to the second point. After 18 months, when T is equal to 18 months. So 18 months you convert it in years, 1.5 years. That is 18 by 12, 1.5 years. That is 3 by 2 years. 3 by 2 years. So what would be the principal here? So P is equal to C is 10,000 e power 0.k, we have got 5, and T I am substituting as 3 by 2. 3 by 2. That is 10,000. So just multiply here. 0.05 into 3, that is 3 5s are 15, 15 divided by 2, 0.1 it does not go, 7 2s are 14, 1 5, e power 0.075, 0.075. See, assume that the rate at which radioactive nuclei decay is proportional to the number of such nuclei that are present in a given sample. In a certain sample, 10% of the original number of radioactive nuclei have undergone disintegration in a period of 100 years. What radioactive nuclei will remain after 1000 years? Take the initial amount as A0. See the first sentence up to this first sentence. The rate at which the radioactive nuclei decay, that is reduces, proportional to the number of such nuclei present. Then in a certain sample, 10% of the original number radioactive have undergone disintegration in a period of 100 years up to the second part. Then what radioactive nuclei will remain after 1000 years? You have to find. Okay. So the radioactive nuclei, let A be the amount of radioactive nuclei at time t. See, and also the rate of changes in this radioactive nuclei is proportional to the amount in time t. So it is dA by dt is equal to, so the amount here is decay, that is reduces. In that case, I take the constant of proportionality as negative. K be the constant of proportionality. So dA by A is equal to minus K into dt. Integrate on both sides. Log A is equal to minus kt. Take plus c, some constant c. Taking exponential on both sides, e power log A is equal to e power minus kt plus c. E and log gets cancelled. A is equal to e power minus kt into e power c. So e power c is some constant, c e power minus kt a. So this is our equation. Now initially, that is when t is equal to 0, they given the initial amount of nucleus A0. A is equal to A0. Therefore, our equation becomes A0 is equal to C e power t is 0. So, e power 0. C is equal to A0. C is equal to A0. So, therefore, the equation 1 becomes A is equal to A0. C is A0 e power minus kt. First part is over. Come to the second part. They given 100 years. In 100 years, 10% of original amount radioactive have undergone disintegration. So when t is equal to 100 years, 10% of the amount is disintegration. So only 90% amount is exist. 90% of A0. 90% only exists for you. Therefore, when t is 100, so A is equal to 90 by 100. 90% only exists. And C is A naught e power minus 100k. T is 100 minus 100k. So A naught cancel, e power minus 100k is equal to 9 by 10. So this is second part equation. Okay. Now come to the question. After 1000 years, what would be the radioactive exist? What would be A? When T is equal to 1000. So what is our A? So A is equal to, again write the equation, A is equal to A naught e power minus kt. So A is equal to A naught, k is 1000, e power 1000 t. So write multiple of 100 because we know e power minus 100k is 9 by 10. Sorry, this is k, not t, k. T is 1000 we substituted. So A naught e power minus 100k power 10. So that is equal to A naught e power minus 100 is 9 by 10 whole power 10. This is your A. So therefore, the radioactive nuclei remain after 10 years. Sorry, after 1000 years. After 1000 years is A equal to A naught 9 by 10 the whole power 10. This is the answer. Thank you.